Good morning. Myself Prabharan J, working as an assistant professor in EC department at SNS College of Technology. In this lecture video, I am going to discuss about the topic is low power memory circuits from the unit 3, that is sequential logic circuit in VLSI design subject. Yeah, let I discuss. Yeah, low power memory circuits are essential in modern electronics devices, particularly a battery powered system such as mobile phones, wearables, IoT devices, and embedded systems like this. Memory consumes a significant amount of power. Many systems, so optimizing memory circuit for low power is critical for overall energy efficiency. Okay, here and some of the key strategies for low power memory design, low power SRAM design technique, low power DRAM design technique. In this lecture video we have discussed about SRAM and DRAM, all of this, and low power non-volatile memory, asynchronous memory design, reduced bitline swing, memory compression technique, sense amplifier optimization, standby power reduction. Uh, okay. Low power memory circuits are designed to minimize energy consumption by employing techniques such as voltage scaling, clock gating, memory banking, data compression, um, and the use of low leakage transistors. These strategies are essential for energy efficient system, particularly in mobile and embedded application where battery life is critical. By optimizing both dynamic and static power, low power memory design ensure that system can operate efficiently without compromising performance. Let me see memory arrays. Memory arrays classified three categories: random access memory, serial access memory, content addressable memory, that is CAM, and random access memory RAM, further classified into RAM, ROM, and serial access memory further classified shift registers and queues. The under the RAM, static RAM and dynamic RAM. The ROM further classified into masks ROM, programmable ROM, erasable ROM, electrically erasable program ROM, and flash ROM. That's it. And shift register, serial in, serial out, and parallel in, parallel out, and queues further classified into first in, first out, and last in, first out. Okay. Array architecture in the context of memory circuits refers to the way memory cells are organized and accessed within a memory array. And this structure is essential for efficiently storing and retrieving data in various types of memory, including SRAM, that is static RAM, and dynamic RAM, and ROM, read-only memory, and flash memory. The design of array architecture influences the performance, power consumption, area, and overall efficiency of memory circuits. Okay. Uh, uh, these are the memory classification, that is read write memory, non-volatile read write memory, and read only memory. ROM classified into static RAM, RAM, dynamic RAM. RAM classified into non-random access வந்து actually first in first out, last in first out, shift register, CAM, and EPROM, and E square PROM, and flash memory under the non-volatile write memory, and mask programmable and programmable memory is the read only memory. And array architecture, the array architecture, um, yeah. The array architecture, in the context of memory circuit, refers to the way memory cells are organized and accessed within the memory array. Basic components of array architecture is memory cell array. The memory cells are arranged in a matrix of rows and columns. Each intersection of a row and a column represent a memory cell that stores a bit of data. Memory cells should be SRAM cells, DRAM cells, flash ROM cells. Word lines are horizontal lines that select a row of memory cells in a array. A word line is activated when the corresponding memory cells are to be accessed. Next one is bit line. Bit lines are vertical lines that carry the data read from or written to the memory cells. The bit line connect to the memory cells in a particular column. And then row decoder. The row decoder is responsible for selecting one of the word lines based on the address input. The row decoder ensures that only one row of memory cell is activated for a read and write operation. Column decoder. Next one is the column decoder select specific bit line for reading or writing the data from or to the memory cells. This allows for data to be accessed in the desired column within the selected row. Okay, that's all. Uh, yeah. RAM versus ROM. Random write and read operation for any cells, which is RAM. Non-volatile data, which is ROM. And RAM volatile data. And most of the computer memory is used in RAM. And mask ROM, PROM all are in under the ROM. Dynamic memory, the static memory under the RAM category. Dynamic RAM, static RAM, EPROM, WEPROM, that is erase and write through electrical means, that is under the ROM. Yeah. Next one is static RAM and dynamic RAM. The basic SRAM cell consists of six transistors arranged in a flip-flop configuration. It requires word line and bit line control for read and write operation. Array configuration for the SRAM which is organized into rows and columns with the number of rows and columns depending on the total capacity. Whereas DRAM cell consists of single transistor and a capacitor. The capacitor stores the data while the transistor acts as an switch. Uh, since the charge on the capacitor leaks over time, DRAM require periodic refresh cycle to retain the data. ROM and okay. Okay. Uh, this is the structure for single transistor, six transistor for SRAM, single transistor for DRAM. This is the structure for DRAM and SRAM. Six transistor SRAM cell. Cell size account for most array size. Already we have discussed SRAM sizing. Okay. ROM. to store constant control information and program instruction digital systems to provide a fixed specified binary output for every binary input. Simple combinational boolean network which produces a specified output value for each input combination for each address. Storing binary information at a particular address location can be achieved by the presence or absence of a data path from the selected row, that is word line, to the selected column, that is bit line, which is equivalent to the presence or absence of a device at the particular location. Okay. If you have any doubt, means you can ask me through the comment. Yeah, we will meet in next video. Thank you.